The capacitor has been charged up to 5 volts. So charged, it is connected to the circuit shown at t equals 0. Find the amplifier output voltage, this voltage, Vx, for t greater than 0 as a function of time. So the initial voltage of this capacitor at t equals 0 is 5 volts. That's where we start. The first step is identifying the nodes I will be writing equations for. Node 1, node 2. What about this one? Well, this one happens to be the output voltage of the amplifier, and we had been strongly advised not to write a KCL equation for that node. So those are the two nodes we will be writing equations for. Negative feedback? Yes, there is negative feedback. There is a connection between the output of the amplifier and the inverting input. The negative feedback equation is, to write the KCL equation for each one of the nodes, first I have to specify the branch currents, which I do arbitrarily like this. Branch currents. Now we can write KCL equation for node 1. Current of the top is Vx minus V1 over 10. KCL equation for node 2. Currents that go in, V1 minus V2 over 10. That is equal to the current coming out of the node. This current is 0 amps, of course, because this is an ideal op-amp. The current through the capacitor is C dV dt. C dV2 dt, given that direction of the current. Now we have 3 equations and 3 unknowns. Let's work through them. I will replace Vx, according to this, by V2, and from KCL1 I will solve for V1 as a function of V2. This equation becomes this one. I can multiply the whole equation by 10 and then move this to this side and V2 to the other side, and I end having 2 times V2 equals 1, 2, 3 times V1. I can substitute V1 as 2/3 of V2. And that is exactly what I'm going to do in this equation. I can multiply this equation by 10, and that I do, and substitute V1 for 2/3 of V2. The equation becomes 2/3 of V2 minus V2 equals 10 times C dV2 dt. This is a 2. This 2 is really amorphous. Well, this equation is simply 10C dV2 dt plus 1/3 of V2 equals 0. This is a differential equation we know the solution for. The solution has a time constant that is 10C divided by 1/3, 30C, and has a final value of 0 and an initial value that is, according to this, the initial value is initial value of V2, which was 5 volts. So the voltage V2 starts at 5 volts, ends at 0, and proceeds with this time constant. In short, the voltage at X is 5e negative 3333t. And that is the voltage at the output as a function of time for t greater than 0. Thank you very much.